All right, this is section 11.2. Inverse equations. Corner seats, move your chairs, please. Face me. Tonight's homework is page 665 through 668. Here's some vocabulary. I want you to define numbers 1 through 4, and then we're going to do numbers 1 through 24. Sean, will you get them? Put them in alphabetical order. Today we're going to be going over how to find the inverse of a function. So yesterday we talked about to decide if it's invertible, and now we're going to decide how to find what the actual inverse is. So let's just jump into an example here. It says to find the inverse of the equation. So let's say I have f of x is equal to 2x plus 1. Well, I know that if I plug in points to my equation, yes? Yes, I would love to, but then the recording won't work. So, sorry. How's that? Is that any better? How about switch the lights, you guys? See if that's any better. Somebody's switching. So I know that the actual function is going to have some points, and then the inverse is going to have the switched points. Is that better, girl? That one's better? Yeah? Okay. So if I plug in -2, -1, 0, 1, and 2, if I plug in 2, that's going to be 5. If I plug in 1, that's going to be 3. This one's going to be 1. -1, -2. And I know that the inverse is going to have the switched points. So I know that this inverse is going to have points -3, -2, -1, -1, 1, 0, 3, 1, and then 5, 2. Question is, how do you find the equation of this inverse? That's what we're going to be working on today. Today's objective is how to find the equation for this inverse. Now clearly I'm not going to sit here and try, guess and check. Oh, I wonder if it's this equation. I wonder if this is it. I wonder if this is it. So what we're going to do is there's actually a procedure in place in order for us to find the equation of an inverse. Step 1 is to switch your x and your y's in the actual equation. And then step 2 is to solve for y. So you're going to take your original equation, switch your x and your y, and then solve for y. Switch your x and your y in the original equation, and then solve for y. All right. So if I want to find the equation of the inverse, if f of x is 2x plus 1, so that's the same thing as y equals 2x plus 1, I want to find the equation of the inverse. First step is to switch my x's and my y's, so I'm literally going to switch these two letters. I'm going to copy it with the x equaling 2y plus 1. That's step 1. And then step 2 is to solve for y. So that means I'm going to subtract 1 on both sides. So that's x minus 1 equals 2y. I'm going to divide both sides by 2. So y equals x minus 1 over 2. So that means the inverse is x minus 1 over 2. Now the table that we created should match this equation. When I plug in -3, I absolutely get -2. And if when I plug in -1, I get -1. And when I plug in 1, I get 0. And when I plug in 3, I get 1. And when I plug in 5, I get 2. So we don't have to guess and check. We can now switch our x into y and solve for y. And that's what we're going to be doing for numbers 1 through 24 tonight. Questions on example 1. How can you check if your answer is right tonight? What do you know about the tables of the two? How can you check if your answers are right tonight? Make a table for the original and then make a table for your answer. And what should be true about the two tables? They should match, right? The x's and the y's should be switched, okay? So tonight, after tonight's homework, you shouldn't be like, oh God, I hope I did this right. Every single one can be checked. How can you check it graphically? What's the first thing we did on Monday? How can you check it graphically? Kind of get off the computer there. Huh? It should pass which test? Okay, it should pass the vertical if it's a function. It should pass the horizontal if it's invertible. But also, you should be able to take a point on the original, switch the points, and make sure that's the point on the inverse. Right? Okay. So hopefully after tonight's homework, you should come back tomorrow with, okay, you shouldn't wonder if you got it right. You either come in tomorrow with, I got them all wrong, I don't know what I'm doing wrong, or you're coming in tomorrow with, I'm good, I got them all right. Because you should be able to check each and every single one. Michaela, please. Example 2, and then we could do a doyo. We say f of x is equal to the cube root of x minus 5. They want me to find the inverse. First thing I'm going to do, what is Destiny? What should I do first? What shall I do first? Can you change this to a y for me? Tell me what to put. Yeah, so instead of f of x, I should put y. So y equals the cubed root of x minus 5. That's the equation. But what's step 1 tell me to do? What am I supposed to do with my x and my y? Switch them. So x equals the cubed root of y minus 5. All right, how do I solve for y here? What do I need to do with that cube root? What's the opposite of a cube root? What's the opposite of a square root? Square. So what's the opposite of a cube root? Cube. So you're going to cube both sides. Now what, Mikhail? This goes away, right? And what do you get over here? X cubed is equal to y minus 5. I'm going to add 5 to both sides. y equals x cubed plus 5. And I'm going to write it as f of inverse of x is equal to x cubed plus 5. Go ahead and check our answer. Let's make a table for f of x. Then we'll switch it for the inverse and make sure that those points are switched. I'm going to be smart about the numbers I choose because I don't want to plug in 0 and then do the cube root of 5. Like, I'm not trying to do all that. What are you talking about, Miss Riad? These numbers right here, I'm not going to plug in 0. 0 minus 5 is 5, and the cube root of 5 is, I don't want to do with that. So I want to be smart about the numbers I pick. I'm pick 5. 5 is good because 5 minus 5 is 0, and the cube root of 0 is 0. So I'm going to pick better numbers. So I'm going to pick 5, and I'm going to get 0. What's another smart number? Do you guys know your cube roots? Like what's 1 cubed? 1, right? So what can I put in here to make this say 1? Because the cube root of 1 is easy. 6. So if I plug in 6, what's 6 minus 5 is 1. Cube root of 1 is 1. I just need one more number. I don't think I need more than 2, more than 3. Let's do one more. What's another cube root? What's 2 cubed? What's 2 cubed? What's 2 cubed? 8. How can I make this say 8? What minus 5 gives me 8? 13. So I'm going to plug in 13. You got with me? What is 13 minus 5? 8. What's the cube root of 8? 2. And that should be plenty. What do I do with these points now? Switch them and make sure it fits my new equation. Does it? Does it work? What do you mean does it work, Miss Riad? Do these points fit in here? If I plug in 0, do I get 5? If I plug in 1, do you get 6? If you plug in 2, do you get 13? So you know your inverse is right. There's no like, oh, I hope I'm right. What do you guys think? Pretty doable? Alright, here's your doyo. Your doyo is to find the inverse and check. F of x is equal to 3x minus 1 over, God bless you, 2. Oh no.
I got 2/3 x plus 1.
2/3 x plus 1?
Yeah, 2/3 x plus 1.
Kathleen, what you guys got? Same thing, but not really, because that means it's 1/3 over there. Mia, what'd you get? Okay, so you're almost there, Dylan. You just gotta make sure everything's divided by 3. Liz, what'd you guys get? Elizabeth, what did you guys get? So the whole thing over 3? Daisy?
2x plus 7.
Okay, so it sounds like you guys got this. Am I right? And did you guys use your table to check? Jessica, can you tell me the table that you plugged in? Okay, well give me 1 point. What did you plug in? You plugged in 1 and you got, okay. So here, can you give me another point that worked? Like what'd you plug into the original equation?
3.
Okay, and when you plug in 3, what did you get?
4. Negative 4. No, yeah, 4.
Josh, what'd you get to plug in? Give me 1 more point. me? Yes, please. Okay, but we don't really want to deal with fractions, but we want this to be divisible by 2, so that means I have to plug in an odd number. So what happens if you plug in 5, guys? What's 3 times 5? Minus 2, minus 1? Divided by 2? Alright, so let's see if the inverse works. Jashawn, can you tell me if 1, 1 works for this guy? Okay. Can you tell me if 4, 3 works for this guy? Hmm? Sorry, I'm blocking it. I'm so sorry. It does? Okay. And how about 7, 5? All right, so we know we're good. So Dylan, had you checked yours, you would have seen the mistake because it actually has to be the whole thing divisible by 3. All right, any questions on the doyo? All right, let's go back to math. Yeah, I want you to do at least 6 concepts by Friday. So let's log in and make sure you get another 2 down. If you're done with your 6 concepts, you can work on tonight's homework. Anybody finish their 6 last night that I don't know about? Ash, you're good then. You can work on tonight's stuff. Let me see the end of tonight's homework though, because I want to make sure I went over the hard stuff. Thanks, Riad. Oh, we need to go over domain and range. I'm stopping in about 7 minutes because I need to go over domain and range. Corner seats continue, so we want to remember something about our domain. Remember 2 rules about square roots and denominators is that denominators can never equal 0, so that's going to be excluded from your domain, and square roots can never be negative, so that's going to be excluded from your domain. So that includes like 4th roots and 6th roots and 8th roots, because all those even roots cannot be negative. Odd roots can be negative because you can do the cube root of -8. That's totally possible. This is possible. Not the square root. The cube root of -8 is possible. All right. So when we're deciding the domain and the range of anything, let's go back to example 2. And I went ahead and put it in my graphing calculator. Example 2 is the cube root of x minus 5. Does this equation have a denominator? No, so I'm not even going to worry about this. Does this equation have a square root or a 4th root or a 6th root? No, so the 2 things I need to be very careful of don't even exist for my domain here. So the domain just means what numbers are you allowed to plug in? Well, anything. So if I go back to example 2, we'll call this example, this is example 3, and we're going to refer to example 2. And the equation is f of x is equal to the cube root of x minus 5. Let's answer some questions. The domain is going to be all real numbers because there's no denominator that's going to make it 0, and there's no square root. So we're good. Those are the things we need to worry about. So the domain is going to be -infinity to infinity. If you're not sure, well, look, graph it. Remember when we talk about the domain, we're talking about walking across the x-axis. Do you see any asymptotes? Do you see anything breaking your graph at all? So the domain is all real numbers. We're good. The range means you go up and down the elevator. And Doesn't look like anything's broken as well, so you're talking about all real numbers here. Now, how do you find the x and y intercepts? This is from chapter 4, 5, 6, and 7. How do you find the x-intercept again? Plug in 0 for what letter? Y. How do you find the y-intercept? Good. So if I want the x-intercept, I'm going to plug in 0 for y. And if I want the y-intercept, I'm going to plug in 0 for x. This one's easier. Let's do this one first. Plug in 0 right here. What's 0 minus 5? Negative 5. What's the cube root of negative 5? Well, I don't know. So let's go here. Let's do the cube root of negative 5. Oops, that's going to give me an error. Negative 1.70. Negative 1.7. And how do you find the x-intercept again? Plug in 0 for y. So you're going to go 0 equals the cube root of x minus 5. What do I do to both sides? Cube it. So you get 0 equals x minus 5. So x equals 5. And that's the second part of tonight's homework.